Perfect. Now we continue with the next one. I'll prepare the next exercise, which is neural networks 1. And then we can start. Drink a bit. Perfect. Let's start here. Hochladen. No, this shouldn't be that one, right? It's 5, not 0.7. Ah, that's fine. Yes. Perfect. Perfect. Let's begin. Ah, do I have the... Yeah, microphone is working. Make it a bit lighter. It's too bright. Yeah, that's fine. Perfect. Let's begin. Let's remove all of this. We already did the exercise number 4. Let's go to exercise number 5. We just translated it. The preparation. It's dark. Data preparation. I might close a bit the windows because it's hard to see. Is it too dark? No? No, it's fine. Perfect. Let's go right left this. Perfect. Maybe now it's too bright. I'll make it a bit dimmer. Perfect. Seems like the right color. Maybe a bit lighter. Is it left, right? Yes. Perfect. Let's begin again. So we have the cell, same thing as before. Data preparation, when we have this test, enlarge real data again. Yes, clean and convert data, that I did that very nicely. No, the section shows how to train an extremely simple neural network, just one neuron with PyTorch on data using the small. Maybe we should watch a small video about it. Yeah, maybe we do neural networks. Maybe watch these videos. How long is the course though? Because it's like super long. Yeah. Wait, let's see if you guys can see. Also this, I'll move it here. There's just one thing, I'll watch this in another tab. See, 1 second. Here. So I can keep my speed chat for myself. I keep my speed chat for myself. And the sound should come from, let's see, properties.
Extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea. while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this, and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network quote-unquote learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo here, because at the end of the two videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants, but in these two introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills.
Oh my god.
This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network.
Give me 1 second, guys. Yes.
Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between, called the hidden layers, which, for the time being, should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons, and admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16? Well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing? Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now, in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these subcomponents. That anytime you feed in an image with, say, a loop up top, like a 9 or an 8, there's some specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents corresponds to which digits. Of course, that just kicks the problem down the road, because how would you recognize these subcomponents or even learn what the right subcomponents should be? And I still haven't even talked about how one layer influences the next, but run with me on this one for a moment. Recognizing a loop can also break down into subproblems. One reasonable way to do this would be to first recognize the various little edges that make it up. Similarly, a long line, like the kind you might see in the digits 1 or 4 or 7, well, that's really just a long edge, or maybe you think of it as a certain pattern of several smaller edges. So maybe our hope is that each neuron in the second layer of the network corresponds with the various relevant little edges. Maybe when an image like this one comes in, it lights up all of the neurons associated with around 8 to 10 specific little edges, which in turn lights up the neurons associated with the upper loop and a long vertical line, and those light up the neuron associated with a 9. Whether or not this is what our final network actually does is another question, one that I'll come back to once we see how to train the network. But this is a hope that we might have, a sort of goal with the layered structure like this. Moreover, you can imagine how being able to detect edges and patterns like this would be really useful for other image recognition tasks. And even beyond image recognition, there are all sorts of intelligent things you might want to do that break down into layers of abstraction. Parsing speech, for example, involves taking raw audio and picking out distinct sounds, which combine to make certain syllables, which combine to form words, which combine to make up phrases and more abstract thoughts, etc. But getting back to how any of this actually works, picture yourself right now designing how exactly the activations in one layer might determine the activations in the next. The goal is to have some mechanism that could conceivably combine pixels into edges, or edges into patterns, or patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then, take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about. And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker. When you compute a weighted sum like this, you might come out with any number, but for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range between 0 and 1. And a common function that does this is called the sigmoid function, also known as a logistic curve. Basically, very negative inputs end up close to 0, very positive inputs end up close to 1, and it just steadily increases around the input 0. So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like -10, to this weighted sum before plugging it through the sigmoid squishification function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active. And that is just one neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer. And each one of those 784 connections has its own weight associated with it. Also, each one has some bias, some other number that you add on to the weighted sum before squishing it with the sigmoid. And that's a lot to think about. With this hidden layer of 16 neurons, that's a total of 784 times 16 weights, along with 16 biases. And all of that is just the connections from the first layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them. All said and done, this network has almost exactly 13,000 total weights and biases. 13,000 knobs and dials that can be tweaked and turned to make this network behave in different ways. So when we talk about learning, what that's referring to is getting the computer to find a valid setting for all of these many numbers so that it'll actually solve the problem at hand. One thought experiment that is at once fun and kind of horrifying is to imagine sitting down and setting all of these weights and biases by hand, purposefully tweaking the numbers so that the second layer picks up on edges, the third layer picks up on patterns, etc. I personally find this satisfying rather than just treating the network as a total black box, because when the network doesn't perform the way you anticipate, if you've built up a little bit of a relationship with what those weights and biases actually mean, you have a starting place for experimenting with how to change the structure to improve. Or when the network does work, but not for the reasons you might expect, digging into what the weights and biases are doing is a good way to challenge your assumptions and really expose the full space of possible solutions. By the way, the actual function here is a little cumbersome to write down, don't you think? So let me show you a more notationally compact way that these connections are represented. This is how you'd see it if you choose to read up more about neural networks. Organize all of the activations from one layer into a column as a vector. Then organize all of the weights as a matrix, where each row of that matrix corresponds to the connections between one layer and a particular neuron in the next layer. What that means is that taking the weighted sum of the activations in the first layer, according to these weights, corresponds to one of the terms in the matrix vector product of everything we have on the left here. By the way, so much of machine learning just comes down to having a good grasp of linear algebra, so for any of you who want a nice visual understanding for matrices and what matrix vector multiplication means, take a look at the series I did on linear algebra, especially chapter 3. Back to our expression, instead of talking about adding the bias to each one of these values independently, we represent it by organizing all those biases into a vector and adding the entire vector to the previous matrix vector product. Then as a final step, I'll wrap a sigmoid around the outside here. And what that's supposed to represent...
Give me 1 second, guys. I don't know if someone is watching. If someone's watching, let me know. If no, I have to stop it for a moment. Yeah, I think nobody's watching. I will pay attention soon, but I need to fix this.
patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then, take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about. And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker. When you compute a weighted sum like this, you might come out with any number. But for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range between 0 and 1. And a common function that does this is called the sigmoid function, also known as a logistic curve.
Got lost, sorry.
That squishes the real number. So a common thing to do is
the
range between
0 and 1.
0. So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like -10, to this weighted sum before plugging it through the sigmoid squishification function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active. And that is just one neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer. And each one of those 784 connections has its own weight associated with it. Also, each one has some bias, some other number that you add on to the weighted sum before squishing it with the sigmoid. And that's a lot to think about. With this hidden layer of 16 neurons, that's a total of 784 times 16 weights, along with 16 biases. And all of that is just the connections from the first layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them. All said and done, this network has almost exactly 13,000 total weights and biases. 13,000 knobs and dials that can be tweaked and turned to make this network behave in different ways. So when we talk about learning, what that's referring to is getting the computer to find a valid setting for all of these many numbers so that it'll actually solve the problem at hand. One thought experiment that is at once fun and kind of horrifying is to imagine sitting down and setting all of these weights and biases by hand, purposefully tweaking the numbers so that the second layer picks up on edges, the third layer picks up on patterns, etc. I personally find this satisfying rather than just treating the network as a total black box, because when the network doesn't perform the way you anticipate, if you've built up a little bit of a relationship with what those weights and biases actually mean, you have a starting place for experimenting with how to change the structure to improve. Or when the network does work, but not for the reasons you might expect, digging into what the weights and biases are doing is a good way to challenge your assumptions and really expose the full space of possible solutions. By the way, the actual function here is a little cumbersome to write down, don't you think? So let me show you a more notationally compact way that these connections are represented. This is how you'd see it if you choose to read up more about neural networks. Organize all of the activations from one layer into a column as a vector. Then organize all of the weights as a matrix, where each row of that matrix corresponds to the connections between one layer and a particular neuron in the next layer. What that means is that taking the weighted sum of the activations in the first layer, according to these weights, corresponds to one of the terms in the matrix vector product of everything we have on the left here. By the way, so much of machine learning just comes down to having a good grasp of linear algebra, so for any of you who want a nice visual understanding for matrices and what matrix vector one of these values independently, we represent it by organizing all those biases into a vector and adding the entire vector to the previous matrix vector product. Then as a final step, I'll wrap a sigmoid around the outside here. And what that's supposed to represent is that you're going to apply the sigmoid function to each specific component of the resulting vector inside. So, once you write down this weight matrix and these vectors as their own symbols, you can communicate the full transition of activations from one layer to the next in an extremely tight and neat little expression. And this makes the relevant code both a lot simpler and a lot faster, since many libraries optimize the heck out of matrix multiplication. Remember how earlier I said these neurons are simply things that hold numbers? Well, of course, the specific numbers that they hold depends on the image you feed in. So it's actually more accurate to think of each neuron as a function, one that takes in the outputs of all the neurons in the previous layer and spits out a number between 0 and 1. Really, the entire network is just a function, one that takes in 784 numbers as an input and spits out 10 numbers as an output. It's an absurdly complicated function, one that involves 13,000 parameters in the forms of these weights and biases that pick up on certain patterns, and which involves iterating many matrix vector products and the sigmoid squishification function. But it's just a function nonetheless. And in a way, it's kind of reassuring that it looks complicated. I mean, if it were any simpler, what hope would we have that it could take on the challenge of recognizing digits? And how does it take on that challenge? How does this network learn the appropriate weights and biases just by looking at data? Well, that's what I'll show in the next video. And I'll also dig a little more into what this particular network we're seeing is really doing. Now is the point I suppose I should say subscribe to stay notified about when that video or any new videos come out, but realistically, most of you don't actually receive notifications from YouTube, do you? Maybe more honestly, I should say subscribe so that the neural networks that underlie YouTube's recommendation algorithm are primed to believe that you want to see content from this channel get recommended to you. Anyway, stay posted for more. Thank you very much to everyone supporting these videos on Patreon. I've been a little slow to progress in the probability series this summer, but I'm jumping back into it after this project, so patrons, you can look out for updates there. To close things off here, I have with me Leisha Lee, who did her PhD work on the theoretical side of deep learning, and who currently works at a venture capital firm called Amplify Partners, who kindly provided some of the funding for this video.
That's nice. I just think I just have this on so I cannot see the YouTube productivity mode. I have to turn it off. Yeah. See the next one.
Last video, I laid out the structure of a neural network. I'll give a quick recap here, just so that it's fresh in our minds, and then I have two main goals for this video. The first is to introduce the idea of gradient descent, which underlies not only how neural networks learn, but
And just leave it at the moment, and then we can start doing the exercises. Here. Hello, Louis Fitness. Just doing some exercises on machine learning. We're now learning neural networks. So we will start with it. How are you? Welcome to the stream. Yes, I am from Colombia, so it is a Spanish accent. Let's see. Let's see where it is. Provided on hot encoding. Missing stop words automatically removed. Oh, nice. So you like doing cardio and then watching streams? That's cool. Very cool. Are you just walking? Are you running? Or what kind of cardio? No, I'm from Colombia, from South America. But I live in Germany. On the bike, nice. Mm. I've been to Cartagena once. It's beautiful. Ah, nice. Where are you from? If I may ask. America. Ah, nice. It's very early there, right? I guess depends where from America you are, but it still should be pretty early there. Not that much actually. Just sometimes, but not really that much. I mean, I've been living here in Germany for a long time. But yeah, maybe when I graduate, then I'll travel a little bit more. Linear sigmoid. Uh, what is this linear thing? No, not this one. Stop. What does the linear represent in? Good beaches? Not really. There's a couple of beaches, but I wouldn't say they're good beaches. Water is really cold. In Germany is pretty cold country. I mean, in summer it's very pretty, but it's more of a lake thing. Like you would go to the lakes or to the rivers, not so much to the sea. We have seas, but yeah, like I would go to other places like Spain for example, or South America for a beach, not to Germany. Oh, that's linear. That's cool, yeah. Yeah, Colombia is very nice with the beaches and the people. Mm. More open about what? About being topless? Or about what? Yeah, I mean, isn't the US also like that? Or they don't like you being topless? I think the US is pretty topless, not like I've seen videos of those fitness beaches and stuff like that. But for example, Germany is also super free with it. Like people normally, there are many Germans go naked to the lakes and to the rivers. Like Germans are very free about, oh, it's not allowed there. Wow. So you have to wear, wait, what? Wait, you're a girl, right? I was very, getting confused. Like, what's the problem with being topless, right? Because you're a woman, no? Or you're not? Ah, yeah. So I thought you were a guy. I was like, oh, weird. Oh, yeah, sure, sure. But I mean, Germany is freer than both of them combined. Like, Germany's full with beaches. Like, all German beaches, you will find Germans that are naked. It's a very normal thing. Like, it's nothing. And everywhere, like, I think nudity in Germany is very normal compared to yeah, it is okay in Colombia, but like not super common, I would say. Like not as Germany. In Germany, it's very common. Like also in the changing rooms and showering with other people, you you just shower naked and then change naked next to the other person. I think nakedness in Germany is way more normalized than in other countries. Mm. Mhm. Mm. Let's see, okay. Object. We initially the function of the loss which we want to, and it is the binary crystal triplet. Binary cross entropy loss. Training. Now I finally get to training in each epoch. A small training step takes place with the chosen optimizer. All outputs are calculated from the input that the loss is calculated. So loss. Where's criterion? Can I find it? No. Criterion. This one. Where's criterion? Here, initialize the optimizer. Binary log loss. Optimizer. Outputs criteria. Yeah, I'm back. I just went to eat something and now I'm coming back for the next exercise. Let's see how much we can do today. Welcome back, N. Wait, you missed my question. What did you ask, Louise? No, I answered you, right? Like, you asked me if in my hometown is common. I think in Colombia, no, except if you really go to specific naked beaches. But in Germany, yes, in Germany it's very common. Yeah, this stream is also on Twitch, Nadine. If you see in my description, you can see the Twitch link. And maybe even sometimes better because for some reason on YouTube there's always like a 10 seconds delay. So if you want to join on Twitch, that's better. Like I think when you were there were like 5 people talking before I left, and most of them were Twitch, but today is just starting slow. Sorry, I said I won't call you Nadine. I'll call N. I forget. Sorry, Louisa, that I missed your question. Or did you have another question? If you have another question, I'm here to help. Let's see. That goes backwards. Depends what your goal is, right? Also depend the context. Like if you're in work context and you know how to code and everything, it's totally normal to like ask code to make code or explain AI. If you're trying to learn, it also depends. Like, for example, I wouldn't tell it to like solve, I don't even know, your task application real data. Okay, I wouldn't tell it like do this for me, but I would tell him like explain me how it works. For example, right now I'm trying to understand how it works, so it makes sense. Or if you have box as well and then it takes you a long time to figure out, it's perfectly fine. And if you're learning, it's perfectly fine to ask AI. If you already know to code, then it's normal to just ask AI, see if it finds it quickly. If not, you just look yourself. Train extract with the same environments on a large Kaggle data from 1.3. For this contain training and test data. And I guess let's add this. Hello, Obito. Nice to see you here. Also, as I told N before, you can also join me on my Twitch stream down there. Sometimes there's less of a delay. How are you, Obito? Which method did here? Gradient descent. Oh, that's correct. The question center. Logistic regression model is optimization algorithm. Using every single layer with a sigmoid activation with. I see. Yes, because I went to lunch and now I'm back to studying. It's just streaming helps me to get focused and start working. It's like a way for me to studying without getting distracted. Well, I might get distracted talking, but that's better than getting distracted on, I don't know, TikTok or watching videos. Train the same simple neural network structure with the same parameters on the large Kaggle data from 1.3. Okay. Oh, what did I do? No. Here, code. From 1.3, this one. Maybe I should put them side by side. I think it's better if I have a copy and then I can look the upper part. Let's see. Now we can like maybe join this too. No, not this. Not what I wanted. Thanks. I wanted a side by side split view. Yeah. Should I put some background music? What do you guys think? Maybe I should. Maybe it would make the stream a little bit more nicer to listen to. Let me maybe get some background music first. YouTube. No copyright. Let me know if it's a bit loud. Maybe it is. Put Madara-fied. The problem, like the music, the problem is that then it gets copyrighted, and then I cannot stream properly. No, I wasn't listening to anything. I normally don't play it. The music I listen is a bit different. I think this might help for everyone to relax. Now, how do I minimize this? That would be nice to know. Also, let me know if it freezes, because sometimes my computer freezes when I run the music too. And then the video just freezes. Perfect. So now we have both, and now I can like go up and check. So train the exact same similar with the parameters on the large Kaggle database. Test train. Just do this on real data yourself. So this is one hop encoding. So we do. Oh, we already have it, right? One hop encoding. Let's do one hot encoding. Then we get the vectorizer equal count vectorizer. I really not sure if this is gonna teach me anything, because this will be a lot of copy paste, but like, let's see. Oh, what are you guys doing? Are you also like coding your stuff or relaxing, or what are you guys doing in, Obito? drop with Mandara fight 1 versus 8,000. I know, but like, you know, like against the what is it? The ninja. I forgot the name of the whole thing. The Ninja Alliance or whatever. It's nice, but like I don't want to get the video then with copyright, because it might have like copyright music and stuff like that. Or the sound might like be copyrighted. I had it already, but then it just like sent me a thing that I should be careful with putting like copyright stuff. That's why I had to like put the no copyright music. Not I would do it. I mean, large stuff is crazy, yeah. Small stuff is crazy, yeah. Where is it come from? Sorry, where's the first one? I really don't know. Like, for me, what I do is listen to what I like. Not really lo-fi or anything like that. I just put lo-fi because, like, I think people enjoy it and it's not very intrusive, so it's nice. But normally, I just listen to what I prefer. Give me 1 second. I forgot something. Oh, so I'm gonna bring some water. So I'm a bit thirsty. Be right back, guys. So what are you guys doing? You didn't answer my question. Only if you want to answer. It's fine if you don't. Ah, okay. Obito, thanks for coming. Always nice having you here. stop encoding. Yeah, we're doing this. This does that. No, we need this. Now we probably do. Let me know if the music is too loud. I can lower it a bit. Hello, Thanos Bay. Welcome back. How are you? I should put sorry. It's cool that you keep doing experiments. For me, I'm just in the next exercise with neural networks. It's not that fun though, because it feels a lot of... There's an example at the beginning and then just have to do it with large data. But I guess more exercises will come and we'll see. You're only 16! What? And you're so smart, oh my god. No way. Really? Crazy. Well, props to you. Oh my god. Crazy. How long have you been like coding and stuff? I mean, really? Crazy. Because young people are amazing. I think when I learned coding, you were probably like, what? Oh my god. No way. You were like 8 years old. Why not? I started learning coding. Crazy. When did you start learning coding, or this edgy groups as a way to signal status between 12 and 13? Wait, wow, that's crazy. Are you like a super smart kid? Maybe? You're probably right, like 10 or 11 is super young. Like when I was 10, I don't know, like a bit dumb. What do you mean with non-linearity? Yeah, but maybe it's the best way, the way you did it, right? I mean, I'm just doing a structured process, I have to. Maybe it's because you enjoy it. Enjoying also helps a lot to like learn stuff. And I don't dislike it. Don't get me wrong, but like, this is just for like an exam I have, so I'm just preparing for it basically. Watch data set test. I don't have this. I should have it. There was a study where they paid to take an IQ test and not paid them to take an IQ test. The group that was paid got like plus 30 IQ points. So yeah, motivation costs things. Yeah, for sure. I think if you're motivated to learn, it's fun. At your time, I guess when I was 16, I was more into 3D modeling because I think programming always scared me. But then Germany, I took a class for programming and it was really fun. And then I was like, oh, I think that's what I like. And then that's why I picked it. I program was wanting to signal status by learning hacking. What is signal status? Are you too young to, I mean, I don't know, what is signal status? Be cool. So I think the kind where you signal towards your highest levels by doing stuff too. So basically cool. Okay. Yeah, but like you're very young. Like you were very young to like be doing that, right? Like 10 years old, 11 years old. I don't think I was thinking about it at 10 years old. I think I was just like playing video games. Train tensor. I actually got top in my training at that age. Okay, you're a smart kid. Like, let's be real here. You're a smart kid, for sure. I mean, you are like being 16 and being able to do all of that is like crazy. Like, you'll probably have a great future ahead of you, which is really cool. And for sure you will. Like, I think at your age, like even 10, 16, I like learning some stuff like 3D modeling, but like what I really like was just playing video games. I think yes, when I was young for sure, maybe, but like right now, no, I didn't continue doing 3D modeling. I mean, I know how to do it and everything, but I don't know, I never pursued it more than a hobby, to be honest, and then I kind of like stopped doing it for a while. I taught it to a friend though, and he became really good. Now he's like a 3D artist or something. Ooh, what have I here? Not what I want. I mean, I'm pretty good at programming, but not at this Python programming. I normally do like React frontend. I worked on it for 5 years, but yeah. It's just different. This exercise is a bit dumb. Yeah, I get it. But the problem is that I'm not learning this for desire. Like, that's how I do it, for example, for the things I like. For example, that's how I did with React and everything. I just enjoy watching videos and all of that. So I just learn it like normally. But this is just, I have an exam next week, so I just have to study. And then I just have to pass, to be honest. I don't have the time to do that, because the next thing that comes is the thesis, and for that I have to do an Arduino project with like for a machine in a chemistry lab. No, I'm not. I'm just studying for an exam. No, I don't think, maybe in the future, but no, I'm not so much into machine learning, if I'm very honest. Maybe I will, if this thing becomes something fun. But for the moment, I'm just doing it for the exercise, for the exam. So I have to do 9 exercises, and then I get 25% of the grade, and then I have to do the exam next week. I'm just going through the exercises. When I do the 9th one, I can submit it, And yeah, I mean, I could also ChatGPT it, but like I think it's a bit fun to just do it kind of by myself, even though this is very copy paste right now. There's something here. Input size is deprecated. Probably passed a test and a training difference, right? Yeah, probably. I mean, I'm open to it, to be honest. I'm not against it. Just like right now, my focus is, I have both focuses right now. My focus here is to finish this, and then when I finish this, then I have to start my thesis, and then graduate. So these are my focuses right now. Then I can like focus on stuff that I want, but because I also work, and it's like I have to do 20 something hours a week, so I really have like limited time that I can put on things that I enjoy versus things that I have to do. But yeah, I'm open to the idea that there's something that I like, that there would be something that I like. Oh, thanks for following the channel, Thanos. Very nice of you. I think for now, yes. Okay. Thank you very much for joining the channel, talking. Was very nice talking to you. I'm amazed you're like so good at your young age. Like really props. And if I were your dad, I would be super proud for sure. Like pretty sure your parents should be like super proud. So you have like a super smart kid. So yeah, enjoy your day, whatever you're gonna do, or your night. I'm not sure where you are. And then see you next time. Thanks for coming. Hola, feito. Gracias. Tan lindo. ¿Tú me sigues? Sí, sí me sigues. Gracias, feito. Gracias por apoyar. Esta mañana tenía hartos viewers, pero ahora se fueron todos porque me fui a almorzar y volví, ya no hay nadie. Ay, tan lindo. Gracias. Estoy haciendo ejercicios para la última clase que tengo en la universidad de Machine Learning. Entonces este es de redes neurales. Y nada, es como entrenar un modelo para que reconozca si un texto es spam o no es spam, básicamente. Anti-IA, no, pues es como funciona la IA básicamente. Vamos a hacer lo último, probar si funciona y ya. Nada más. Entonces hago stream porque me concentro más cuando hago stream, porque si no hago stream me pongo a ver videos tontos, no me concentro. Vamos a ver. Predictions of labels one data. Y esta porque está acá. Y este donde viene small data df copy test. Ok. ¿Sientes que te ven? Hoy no. Ok, sí, me gusta que me vean porque como que me hace sentirme perra, no mentiras, me hace sentirme como que me toca estar concentrado, ¿sí? Que no puedo estar fingiendo de estoy estudiando, sino realmente me toca estar estudiando. Porque si no, como que, no importa, pero ahorita sí me toca como serio, no puedo poner como anime, Jujutsu Kaisen mientras tengo que estudiar. Necesito llegar también a 50 seguidores en Twitch para poder crear suscriptores. Fui al baño a hacer caca y la caca está súper grande. Me pasa. Más de una manera. Dime, ¿puedo spamarte el chat de cosas asquerosas? No tengo mod. ¿Quieres ser mod? Sí, te puedo volver mod también. Espérate, entro a Twitch, te vuelvo mod. Ahorita nadie está entrando, no sé, a veces los dioses del algoritmo me bendicen y a veces no me bendicen. Creo que es cuando muestro harta piel que me bendicen, pero ahorita mostré muy piel muy tarde. Tenía un bot que hice yo, pero es que lo tengo que correr como localmente en mi computador y me traba el computador, entonces ahorita para estudiar no. Ahora te vuelvo mod. ¿Cómo se te vuelvo mod? Puedo poner como mod y mcz. Está plagado por bots. A mí me llegan a veces mods que me dicen como agrega esto si me los baneo. Como consigue seguidores buenos acá, algo así. A ver, creo que este debe funcionar. pero bueno. ¿Qué? Vamos a intentarle a la IA si es algo malo, porque no sé. Review exercise 4. Did I do it correctly? De la India. Yo también tengo mucho trabajo. Ay, feíto. Sí, me toca trabajar y estudiar y... Ay, no, qué pereza. Ojalá pudiera solo estudiar en vez de trabajar. Tengo el codo también un poco jodido por yo. Entonces no puedo hacer mucho yo. ¿No estás con con el grupito? Sasami los amigos. No, I don't need the evaluation matrix. En las noches. 20. Es que me toca... Cuando termine el examen, es que el examen lo tengo la otra semana, entonces ahorita estoy juicioso estudiando. Exercise número 6. Import pandas as given. Para que lo puedan leer todos. Translate everything to English, but don't touch code. lists. Nice seeing you again here. Welcome to the stream. There might be a little bit of a delay as well on YouTube, so if you have Twitch, you can also join on Twitch on Discord. I'm good. How are you? But if you don't, then it's fine. You can stay here. Don't worry. How are you? so dumb. God. Lay input. Then label. Then we print this. Train tensor. Where is it now? Maybe like this makes more sense. Are you there, Hamza, or you left? Ponte el álbum que hice collab. ¿Dónde está? ¿Dónde lo pongo? A ver, lo pongo. ¿No tiene copyright? Porque la verdad es que si tiene copyright me joden. Me pasó cuando puse la Bayal. Espérate. Bueno, entonces decimos que tenemos el derecho tuyo. Me puedes hacer copyright strike y me jodes. ¡Pam! Ah, porque se trabó. ¿Qué pasa? Está como internet como lento. Pero a ver mientras se carga. Ya. No, pero eso es como. Eso es como para mariconeras porque me está. La cabeza me da vuelta con el sonido. Está chévere, está chévere. Me hace la cabeza. Como si estuviera trabado. Qué chistoso. Sí, exacto. Sí, exacto. Oye, chévere, lo voy a poner entonces siempre porque no había podido encontrar alguno bueno para poner, pero está chévere. Porque siempre la mayoría tiene derechos de autor. Espera un segundo. layer, numbers in the first layer, numbers in the first layer. Let's see, apply the first linear layer activation, apply the second linear and segment activation. How this is how it works. See, mistake, instantiated the wrong thing. Oh wait, this gonna die. Let's check this. So let's go. It's a bit higher. Yes, maybe a bit higher. Perfect. So learning rate. Perfect. Now it worked. Now let's see. So let's run everything. Okay, look at the results. Is it correct? To learn, is it learn the very nice. Let's go with the next exercise. This one we kind of did it with AI, but like time is ticking. I'll be right back. I'll go to the bathroom. You might have in the time we're good on time. So I'll be able to watch JJK later. Which is good. So do this again, clean and convert it. Mm. Hmm. Hmm. Okay. So we still with the same things. Let's open the other one. Oh my god, I've been doing this since 8 a.m. Do we have this? Get this. Yeah, we put it. Large, large. Where are the tweets? Path download clean tweets train df. Focus, focus. It's going fine, but I'm like not being able to focus for much longer. Still have 3 exercises to go. I think I'll do 2. And I might take a rest and then do the last one, which is the important one. Oh, this one is not even that hard. I've been here since like what, 8 a.m.? It's 4 p.m. And you, how are you doing, and Sweep? Could get a 10 minutes break before stand up, early morning meetings today. Ah, nice. Wait, it's 10 a.m. there? So you went to bed very late, probably, no? 10 a.m. on the East Coast. I get up very early. So you got up when I was streaming? So yeah, pretty early, because like I started streaming at 4 p.m. 8 hours ago. So you woke up super early. Normally, yeah. Yeah, I normally wake up at the maybe around that time too. Yeah. Yeah, I normally also wake up around 5, 6 a.m. but not willingly. Just 'cause I have to. But it feels good to wake up early now, I guess. Display feature names. Let's do this. Let's see how it looks. Yeah, for me as well. When I was younger, I would always go super late to bed. But now, like, when on my older times with responsibilities, then kind of wake up earlier, and it feels good actually. Yeah, exactly. Me too. I like it now too. Feels very nice to like do stuff in the morning. I feel I have more energy, and then at night I just rest. It feels nice. I like it. This is not running. Is there a way to see this? Google Colab read-only mode. Viewer way this file. Notion of playground mode. I just make a copy actually. Can I rename it? Then where is it? The split view, then it says here. Yeah. This cannot be, yeah. Has to be this one. Sorry for yawning. I think I'm getting tired. I'll just power through this last 2 exercises. So do this. Learning input. Yeah, but the other way we did it differently. Ah, really? I started when I was 25. Yeah, now I'm 30. But I think just also in the last 2 years, I started getting a better sleep. Nice. And then you at 32, you decided to like do it professionally. Do I open code? Uh, I started coding as a hobby at 25, 26. Yeah, my roommate from college convinced me to do a bootcamp with him. I didn't think I was very good, but turns out I was good enough to get work. Anyway, stand up town. Get some rest. You too. Enjoy your stand up and hopefully see you later. I will be here if you decide to come back, probably. I'm not planning to go in the next 2 hours. Just power through. Thanks for coming as always. Getting distracted. And we do the see if I did it correctly. Just confused. We don't seem to have used the test. Just confused. We just seem to never have used the test one, right? Can you do that? Let's see. See what it does. It gets it. It evaluation mode. Yeah, and let's run all of this. Because yeah, it's weird we're using the train for this, right? It's more here that we get it and then we train. We do the evaluation, we test it there. Let's see how it works. Get a bit stuck, no? So the results were not really that good, right? Precision, recall. The results. How can an extra layer help here? No, don't do it. So what it did is linear 2, sigmoid 2, self-max. Okay, let's just run it. Let's see. Let's just see. Oh, the music is gone. Yes, video pause.
I noticed the lights were on and
Just come
thought
here.
you might be home. I wasn't sure. I don't think the score improved much. That's a keen observation. My god, refined, no. No. I don't want to start like randomly doing stuff. It has to have a solution. I mean, it's fine. Just leave it for this. Go for the next exercise. Not a big plan. The music, of course, that's making me sleepy. I need to put more vibing music. But then I'm gonna get copyright strike. We could do gaming. Maybe for gaming to keep me like more awake. Funk. This is horrible. Horrible.
Ela chega, domina o baile, é foda demais. Gata braba, safada, bagunça meu juízo em paz. Vai rebolando, jogando um corpinho sem dó nem dó. No grave que bate, que bota com bota, que bota com bota, com muita pressão. No batucão ela vem, vem. Sua na pele não para, vai, vai. Corpo no grave, perde a razão. Que bota com muita pressão. No batucão ela vem, vem. Sua na pele não para, vai, vai. Corpo no grave, perde a razão. Que bota com muita pressão. Ela chega, domina o baile, é foda demais. Gata braba, safada, bagunça meu juízo em paz. Vai rebolando, jogando o corpinho sem dó nem dó. No grave que bate.
queen minus woman plus man. Terrible. Other things help me focus. Just one more. Maybe since I'm dark, I'm just gonna open the outside. Maybe lights outside might help me. Okay. Transfer learning occurs when a model is heavily trained on primary journalist task. But go more in depth. Hello. Like, what is a transformer? Be right back. Before starting the exercise, might eat some cereal. Which one? Let's see. Let's open the last one. Okay. I'll ask ChatGPT to translate this. I'm gonna get some cereal and I'll be right back and do the last exercise. And then later I'll do the last one. Yes, accept. No, didn't translate everything. No. Thing to English except the code blocks. Hola, Dae. Acá seguimos sin parar. Acá seguimos sin parar, Dae. Ay, ya es el último. Después por la noche hago el último. Pero voy rápido por un cereal o algo. Porque si no me va a morir. No tengo energía ya. Sin parar. Ya vengo. I'll be right back. Ya vengo. Sí, claro. Toca, Dae, toca. Volví a seguir acá. Esta lo cierro. Clean and convert data, lo mismo de siempre. Provide the relation function, lo mismo de siempre. Oh, tronte. Ups, no quiero mostrar eso, solo tengo que limpiar esto un segundo. Bueno, ¿me puedo escribir con una mano? Vamos a ver un video mientras tanto. Pero copyright, maldita sea. Vamos a ver este video. Mientras... comemos. Se abrió esto.
Lovely day. 내 눈 속에 비친 aerosol. I'm feeling lonely. 그 말을 끝내고 말해줘요, homie. 다시 crying in my room. 숨기고 싶어. But still I want it more.
Maldita sea el copyright.
I give a second
Dios.
chance to Cupid. 날 믿은 내가 정말 stupid. 보여줄게 숨겨왔던 love isn't real. Cupid is so dumb. 또 꿈길을 걷는 everyday. 눈 뜨면 다시 또 flew away. Waiting around is always. 난 솔직히 지금이 편해. 상상만큼 짜릿한 걸까. Now I'm so lonely. 매일 꿈속에서 연습했죠 kiss me. 다시 crying in my room. 포기할까봐. But still I want it more, more, more. I give a second chance to Cupid. 날 믿은 내가 정말 stupid. 보여줄게 숨겨왔던 love isn't real. Cupid is so dumb. I'm so lonely, hold me tightly. 짜릿한 거 원해, really love me truly. 내게 기다림은 없어, I can't wait. 더는 믿지 않아, now I'm gonna make it mine. Love is a lie, I wish my love is right. It's not a joke, so yeah, but show me right now. No more chance to you. You know, hey, don't worry. 꿈속에 매일 밤 someone who will share this feeling. I'm a fool for love, a fool for love. I give a second chance to Cupid. 날 믿은 내가 정말 stupid. 보여줄게 숨겨왔던 love isn't real. Cupid is so dumb. I give a second chance to Cupid. 날 믿은 내가 정말 stupid.
Continuar. Let's continue with the exercises. The exorcists. So, provide a blah blah blah. Now train with vocabulary 1000. Text date. Let's see. Oops. Ya. Así. A ver. Vamos acá. Vocabulary size 1000. Trains reads df text to list, blah 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 blah. See what happens if we run this. We should probably run everything first. Oh my god. So much. The rest. PD is not it's not oh no, it's here. Run all. I'll be right back, guys. Okay, guys, I think I'll stop the stream. I'm not really very focused anymore, so I'll just chill a bit and then continue later. Thanks for everyone who watching, or if someone will be watching later, and see you later if not